Alright, ladies and gentlemen, we're going to take a look at today's lesson. And today's lesson is graphing systems of inequalities. And that really is our only way of finding these. We don't talk about any other way because for inequalities, there's more than one solution. So it's difficult to solve it algebraically and find the one ordered pair. So what we're going to do is look for the intersections of the graph, which means we're going to intersect, or we're going to look and see where the shading intersects. So what we have to remember is that we're going to graph each inequality on the same coordinate plane. So one graph for two inequalities, which is what we saw for equations. You're going to graph the first boundary line. And what I'm going to recommend is y equals mx plus b. So solve for y, get it in y equals mx plus b form, and graph your slope and y-intercept. And then use a dash line for greater than or less than, so that you're not, or less than or greater than, so that you're not closing in that circle. And then a solid line closed in for less than or equal to and greater than or equal to. We want to test a point not on the boundary line, and we're going to talk about this shading. Remember, we can always test 0, 0, and lightly shade the appropriate hat. Then we're going to graph the second boundary line. Same thing, solve for y, get y equals mx plus b, and then use your solid and dashed lines, and then test a point not on that. We're going to test 0, 0. We're going to lightly shade. So those of you who only have a pen may want to invest in a pencil. The solution is found where the shadings intersect, because we're looking for all of the ordered pairs that will work in both inequalities. So let's take a look at what that means. The first equation is already solved for y. We've got y is less than x plus 3. I'm sorry, y is less than or equal to x plus 3. So we're going to start at 3. This is our y-intercept. And so because it's y, we start on the y-axis, 1, 2, 3. And then we're going to count our slope. Our slope is 1, so we go up 1 over 1. So we get this lovely line. It's equal to, so we can make a solid line here. And now we need to test a point. And so you can test the point 0, 0. All right? So we have 0 is less than or equal to 0 plus 3. And 0 is less than 3, so that's true. So we're going to shade less than. Now what I want to point out to you guys, and those who are listening will get this, and we're just lightly shading there, is that because we had y by itself and this was less than, we shade below the y-intercept. So we're shading from this y-intercept and we're shading down because it was less than. So as long as I solve for y, follow my inequalities the right way, I should be able to do that. So let's go through and do it with this one. We're going to minus 2x from each side. We have negative y is less than 5 minus 2x. And we do have to divide by a negative 1. And so what happens here is we get y is greater than, so make sure you do the reverse of negative 5 plus 2x. What that's going to do for you is allow us to do some more things with our shading. So we're going to start at negative 5. So we have 0, 1, 2, 3, 4, 5. And then we're going to go up 2 over 1. And so what happens is on the graph paper I have here, we don't even get our lines intersecting. And that's okay. Our lines don't have to intersect. It's the shadings that we want to have intersect. And so we're going to connect that with a dashed line, because it's just greater than. And so we have to figure out our shading. So like we said, we can test the point 0, 0. And so we have 0 is greater than negative 5 plus 0. 2 times 0. We know this point, this term just cancels off. So we have 0 is greater than negative 5, which is true, which means you're going to shade above the line. And so we end up with a lot of really kind of yucky stuff here. All right, but what we're looking is where the blue and red overlap. Now, one thing you may need to do, guys, is darken in your lines, because these lines are my boundary points. When I look at my line, I only have red above, I have blue and red below, so I want to get rid of this. Pencils come in handy, my eraser's pretty handy. if I dash in this line and follow this specific line here, if I look above the line, I have red and blue. If I look below the line, I have just blue. And so I only keep where the shadings overlap. And so what we find is that we shade in between these two lines. Now that's not always going to happen in between them, but for this case we do. All right? So what you're going to do now is you have an on your own. So if you didn't bring your book home, you'll have to do this in seminar or do this before you come to class. But you have page 160 in your book. So in your green Algebra 2 book. And you're going to do number 30. All right, let's take a look at the next example. We have x is greater than or equal to -2. Because we just have x, it goes through the x-axis at -2. It's going to be a solid line, and it can only go through the x-axis. So that's where we get this vertical line. So try and be a little bit neater with it. It's solid because we have the equals to there. I need x to be greater than -2. A lot of you already have that idea. Greater than is going to the right. But if you test 0, 0, we get 0 is greater than or equal to -2, which is true. And so I want to show you another way of shading. Instead of shading this whole way, what I'm going to do is I'm going to point arrows across the line to see where the shading would go. So I'm taking my time to kind of do these arrows so that I can look and see then where are the arrows pointing at each other? Where are they going to intersect each other at? All right, let's take a look at this problem. Y is less than or equal to -2x plus 1. So we're going to start at 1, and we're going to go down 2/3, down 2 over 3. So we go down 2 over 3, down 2 over 3. We go up 2 over 3, and it doesn't matter that I didn't hit the line exactly. It's going to be a solid line, so we're going to follow those. And then we can test 0, 0. We can see that it says y is less than, so I feel pretty confident that I'm going to shade below this point, but we'll just double check. So we get 0 is less than or equal to -2/3 times 0 plus 1. This cancels out, so I get 0 is less than or equal to 1, which is true, which means I'm going to shade below that. So here, in this region, I only have blue. So when we look in this region here, I only have blue, so I'm not going to shade there. I keep shading below, and if you look, this box here is where I have red and blue arrows. So this is actually going to be the spot that I shade in. Once I find the one section of my graph that has red and blue arrows, I know I don't have to shade anywhere else, so I can kind of take the marks out of that area. So you're going to end up with a nice chunk, a nice triangle, in this case, for their intersections. All right, so your last on your own is on page 160 again. So this is page 160 in your green Algebra 2 books. And you're going to do number 31. All right? Ladies and gentlemen, have a good evening.